So, permutations. The number of permutations arrangements of n different objects taken r at a time is npr equals n factorial all over n minus r factorial. Now, we're going to concern ourselves about this piece at a different time. One other big important thing is n has to be bigger than r. So, if you go math and then probability, you'll find the NPR key. Okay, so let's kind of dive into this. How many three-letter arrangements can be made from the letters of these words? So, 3 letters. Well, that would be 1, 2, 3 if I'm using the fundamental counting principle. In the word wealth, there's 6 total letters, so it'd be 6 times 5 times 4. Which would give me 120 different ways I could arrange that. Or what I could use is this NPR. So the N stands for the number of objects, and the R is the number of spaces. So I go 6 because we have 6 objects, and then I have 3 spaces, and this would give me 120 ways. If you're putting this into the calculator, you'd have to put it in as 6 NPR3. That depends on what operating system your calculator is on, but just so you guys know. And that should equal 120 ways. So moving on, for sandwich, we have 1, 2, 3, 4, 5, 6, 7, 8 letters. So I could look at this as being 3 letters, 1, 2, 3 spaces, 8 times 7 times 6, which would end up giving me 336, or subsequently, I could look at this as being 8p3. Now, either one of these ways is completely acceptable. In some cases, you'll be forced to use one or the other, but as we go through more and more problems, it'll start to become clearer what's going on here. Now, permutations with repetitions. I'm going to ignore this one right here, but when we look at the word C, if I wanted to arrange those letters, well, if I label that as E1 and I label that as E2, SE1, E2 is the same thing as SE2, E1. So what I need to do is I need to find a way to get rid of the repeating letters. And it turns out the way that we do this is just very, very simply by dividing them out. Okay, well, what does that mean? Well, I look at the word database. And for the word database, I have 1, 2, 3 A's. None of the other letters repeat. So I want to look at the number of ways that I can arrange the letters in this. Well, there's 1, 2, 3, 4, 5, 6, 7, 8 letters total. So that would be 8 factorial. Or if you wanted to, you could actually put this in as 8p8, but we're just going to stick with the factorials right now. So it's 8 factorial because I have 8 letters that I'm looking to arrange, but I have 3 A's that are similar. So since I have those 3 A's that are similar, and we cannot tell them apart, what I have to end up doing is dividing out the number of A's that we have. So I go 8 factorial divided by 3 factorial, and this will give me 6720. Mathematical, I have 1, 2 M's, and what I'm going to do is to just sort of keep track of this. I'm going to actually write out my bottom first, and then from here I have 1, 2 A's, so that gives me another 2 factorial on the bottom, and then we have 1, 2 T's, so that gives me another 2 factorial on the bottom. I believe that I've caught all of them. Then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters. So this would give me 12 factorial divided by 2 factorial, 2 factorial, 2 factorial. which ends up giving me a very, very large number. So that's going to be 79,833, or sorry, 79,833,600 ways. That is a lot of ways to arrange those letters. Looking at basketball. So again, for basketball, I have 1, 2 B's. So I'm going to set up my bottom first, 2 factorial. And then from here, I have 1, 2 L's. So that gives me another 2 factorial. And I have 1, 2 A's. So that gives me another 2 factorial. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters total. So that'd be 10 factorial all over 2 factorial, 2 factorial, 2 factorial. And that would end up giving me 604,800. Now, this next example 20 is going to be pretty loaded, so I'm going to restart the video and then we'll start up on this one.